Okay, thanks a lot, Jeremy. Good afternoon. I am Liaz Kamper from Stratascale. And in the past 3 years, almost 3 years, I have a big passion for virtual networking and specifically applying or designing solutions for customers using virtual networking. I'm doing it in Stratascale. Stratascale is a company that has lots of innovation in the field of cloud, and we're taking a software-only solution and we're building a cloud, private cloud, public cloud, soon to be hybrid. And as you can see, our customers get an OpenStack API, also a Neutron API, and they just install our product. Okay, there you go. You have Neutron. Now I have an API. What am I doing with it? So the first question I have is, how many people in this room are actually architecting or designing the network solutions for the customers or their own enterprises? Okay, see one. Great. So my goal first is to allow you to think and do it easier, okay, by having the first methods of actually doing that, okay? And that's for the architects. And if you're a developer, Neutron developer or network developer, then of course, feel free to attend. You'll get a 30,000 feet overview of what people are actually doing with your software and maybe get some ideas. And if you're just looking to sit around and wait for the coffee break, good news, that's right after my talk, then feel free to do that. If you don't recognize the people in the icon, then you shouldn't consider yourself fan or geek. You should reconsider. Okay. I wanted to start with this guy. That's the inspiration for this talk. You probably don't know him. He's a son of a Danish carpenter. I think the second most influential son of a carpenter I know in the human history. His name is Godfrid Christiansen. And if you think that's the guy who invented Lego, you're wrong. That's the son of the guy who invented Lego. And he did two very important things, or influencing things for Lego. First, he invented the clutch power, okay? That's the circle and studs, okay? That makes the bricks actually stick together until they hit the floor or a little brother's head. And the second thing he did, he wrote the patent. As you can see, he depicted also in the patent the fact that you can stick many bricks together. The clerk asked him, how many ways are there to connect the bricks together? He wasn't confused. Godfrid said, before I left home, I calculated it. It's 102,981,500 ways to connect 6 2x4 bricks. Okay, that's impressive, and we're all paying for that patent till this very day. When I look at those bricks, I said, okay, that's the same problem, right? We have Neutron Bricks. Everything sticks together quite nicely, but what do we do with it? Okay, there are probably a gazillion ways to connect them together. We've got the layer 2 bricks, the networks. That's practically a broadcast domain. You can send packets one way to another. We've got the ports. That's how we connect the virtual machines or the network appliances straight to the network. We've got the external network. I'll talk about it in a second. And also the layer 3 bricks, right? The subnets, we all know, virtual routers, and great extension bricks, load balancers, firewalls, security groups. Great. So when I come to solve a network solution for one of our customers, I look at the customer and understand if he's the Batman or the Lego City. The Batman is actually the enterprise. Okay, this is how it goes. The guy says, I want your company, your product in the enterprise, and I'm the administrator. I've got a single tenant. This is practically it. Solve my problem. Great. And then we have the multi-tenant, right? That's the cloud. And the tenant is, I know there's some confusion in the Neutron domain and around OpenStack from tenant and project and domain. So I refer to as Neutron knows the word tenant. Tenant is a sub-administrator that was allocated several resources and is actually managing them. We'll start with a quick and easy solution. Let's do in Neutron what we're all doing in the data center. We'll connect the virtual machines. Virtual machine is a machine, right? It's basically the same computer as anything else. Let's connect it directly to the router. Now, I have an important thing to say. The guy that helped me, the designer that helped me set those slides, when he saw the word router, he only thought about the router in his own house, okay? So stop writing the complaints mails. I know the data center router doesn't have an antenna, okay? But the designer doesn't know any other router. So that's a data center router. And the data center router, in this case, has a DHCP, right? The first of his subnet. And let's connect them together. Fine, believe me, that works. You disable the DHCP on Neutron, you enable it on the router, and it works. The thing is this, Neutron lost control. Neutron doesn't know anything about which IPs the VM, the virtual machine got. He just lost control. If you go to Neutron, you ask him which IP did my virtual machine get, you'll get an incoherent answer, okay? And you'll not be able to use security groups. One word about security groups. Security group are how you actually defend or secure the virtual machine in the port level, okay? That's for anti-spoofing and securing. You're just limiting the ingress and ingress traffic. But since Neutron doesn't know which IP that VM get, then you cannot use anti-spoofing, right? So there's go security group, there go Neutron. You just ask Neutron to supply you a broadcast domain, and this is it. So I know Neutron is going the right way when they're developing the IPAM and so on to actually solve that problem, which is great. But if you're going to go that path, okay, you should consider that carefully, okay, because that's not the best way to go, but if you want to hack it, then fine. Well, this is the obvious way to go, okay? When you install the dev stack, when you install Neutron, and you go, okay, you create the network. This is the network you're creating. You have an isolated VLAN, and that isolated VLAN, the virtual machines are connected to the isolated VLAN. The DHCP is controlled by Neutron. Okay, great. So we have the L2 connectivity. Neutron can control the subnet, IPs, and so on. And you have security groups. That's fine. One small word before I continue. From this point onwards, in my talk, I will be only discussing Neutron when it is deployed, okay? Just like you have it in Stratascale product or anything else. I will not be discussing servers, agents, and so on. So, as I said, Neutron is deployed, you've got security group on, the subnet is on, everything is great. Well, Darth Vader says things are not that great. And the thing is this, if you notice, your VLAN just got a subnet from the network guy, and you just, I want to say used, but you actually wasted. You wasted the whole subnet for the entire network, okay? Network guy doesn't like it, and he's right. And also, you will be using the firewall, load balancer, anything from that specific router. So you're not really using all the benefits of Neutron. But again, that's a good starting point for enterprise solutions. So I think it's great if you know what you're doing. So now we come to the basic solution. Okay, this is where I start from when I design the solutions, and that's using the virtual router, the Neutron virtual router that allows you to isolate the the internal network, which the virtual machines reside on, and the external network. Now I will explain what is an external network. It's a very important notion in Neutron. External network is a network where you're a guest on. Neutron has absolutely no control over an external network, right? It doesn't have any DHCP. It's just got some resources on the external network, meaning the administrator said, okay, you have this VLAN, and you have maybe a range, right? You need to have an IP range. Neutron will be using that IP range for connecting the virtual router on that external network, and of course for public IPs. I will soon explain what are public IPs. And you can do anything on that virtual router, right? You can apply firewall, load balancer, all the goodies, VPN, all the goodies that Neutron can use, you can use now. Okay, so that problem is solved. Now, regarding network security, Neutron knows everything, right, on that network. He knows the IP, he knows what's going in the virtual router. You just told him what is the subnet, what is the external range being used on the external network, so he can solve that issue for you, for security. And you'll not be wasting the whole subnet, okay? So I remind you what I told in the last case. The internal subnet that you're using is not actually has to be routable across the data center. It's not something you can make up, right? Because the virtual machines can see that subnet, but you're not using all of it. You are using the range that the external network was given by the administrator. And as I said, one IP will go to the router. The rest of the IPs are for public IPs. Public IPs are IPs you will be using. You will be associating virtual machines to those public IPs, right? So a virtual machine can be accessed from the network, from the external network, into the internal network with a unique IP. Default use case, web servers, right? So all of the virtual machines can access the internet using a NAT in that virtual router, if you actually enable that. And some virtual machines can be accessed from the external into the internal using public IPs. Of course, you can associate several virtual machines, not in the same time. You can associate a virtual machine to a public IP, and then maybe associate another virtual machine to that public IP, and then you can sort of load balance between them. Okay, and now we're going to the cloud, okay, where we have multi-tenancy. Now, the most important thing to understand about multi-tenancy is that usually when you have several tenants, the basic idea is that a tenant doesn't know about other tenants, right? So we got two tenants, Pepsi and Coke. There's no way you're going to tell Pepsi, you cannot choose those subnets because Coke is using those subnets. Each of the tenants has to think he is alone in this world, and that means also for security. He shouldn't be defending himself from a specific tenant. He might be defending himself from the rest of the world, but not from a specific tenant. So that's the public cloud. Okay, that's the basic use case for a public cloud. I have never deployed any of those use cases in a customer. I'm going to surprise you. There is always something special with each customer we're deploying. But this is the starting point. So for the public, for a self-service multi-tenant, where you actually sell a whole quota to a tenant and saying you will administer your own networks, you will spawn virtual routers, you will spawn virtual networks, you can do your own security. That's the basic way to go. Okay, so what do we see here? We see here a tenant that has several virtual machines and using a DHCP, and it's isolated behind a virtual router, okay? The shared resource here is an external network. The tenant don't know anything other than the quotas they were given and the external network they're connecting to, and the range of IP they got for that external network. As you can see here, I have just duplicated the previous use case, okay? So tenant A and tenant B, they're completely isolated. They don't know of each other, okay? But as you can see, I've allocated everything. Everything is self-service, but tenant B and tenant A are connected. They are connected through the external network. They don't know of each other, but they are connected through the external network. So basically what you need to do is you need to make sure behind the tenant back, that's actually a basic policy the administrator should apply, is applying a basic security policy for tenant A to be secured from the other tenants, even though it doesn't know actually they are there, okay? And this is the last use case I would like to discuss with you. And that's the private cloud or even a public cloud for a guy who's only selling virtual machines. He's only giving virtual machines for his users to use. The basic use case is a CI, right? You have several development groups, and you want to allocate certain virtual machines to certain tenants. So the thing is this: as you can see, the tenants are connected to the same virtual router. Okay, so pros: tenant A and tenant B can actually move traffic between the tenants without using the precious resource of a public IP. Okay? The thing is, they are connected together. So tenant A and tenant B cannot have the same subnet. Okay? So they're aware of each other. And you need to protect them using a firewall or security groups in each of the tenants. Okay? So this is what we call strict control. Either the tenants know of each other, or even better, the administrator knows the tenants are there, and he will make sure they are secure from each other. Okay? And the external router is, of course, the external network is, of course, shared in between them. Now, I want to go back and emphasize one thing. You can use this same use case for strict control, okay? Since this, even in strict control, it will save you a precious resource, which is called the subnet. We had a customer who said, the most important, I want to be strict control. I'm selling only virtual machines. The thing is this: my most precious resource in the whole data center is the subnet. As you can see here, tenant A and tenant B can overlap and reuse the same subnet, right? So he will use the same subnet, everything will be strict control, and he will still be able to sell only virtual machines. Okay, so I've got a debt for you guys. I haven't said it before, but you remember Godfrid back then, the guy from the 102 million and so on. He was way off in his number, and I want to tell you the real number. And that guy actually calculated how many ways are there to connect 6 Lego bricks together. And Godfrid was good in inventing toys, but he was not very good in math. That's the real number. That's over 900 million. And the mistake he did was that he stacked the bricks one on top of each other when you can actually connect the bricks also in that dimension. So the lesson, I think, from this lecture should be, you should also look on, when you're trying to solve things, look at other dimensions. You have, the range is much bigger. You're welcome to take a picture of that QR code. I checked it, it works. It has the transcript of this talk. Everything is detailed in that in the blog. And with this, I would like to thank you. And if you have any questions, then that's the time. Thank you very much. Okay, thank you guys.